Hello everyone, this is Amira. In this video we are going to see how we can build a house price prediction system using machine learning algorithm. So for this prediction system we will be using XGBOOST Regression algorithm. So this house price prediction is a regression problem. Let's try to understand more about this problem statement. Then we will discuss what is the approach we will be taking to solve this problem. And then we will get into the coding part. So first of all, let's understand what is the meaning of regression. So generally, machine learning algorithms classified into two types. They are supervised learning and unsupervised learning. In supervised learning, we will train our machine learning model with lots of data. So we will be provided with labels. So in this house price prediction case, the label is nothing because the price is what we are trying to predict. So price will be our label. So in the case of unsupervised learning, we will be training our machine learning model without this label. Okay, this supervised learning is further classified into classification and regression. So you can see what is the mean by classification and regression in the slide. So basically classification is about predicting a class or discrete value. Okay, so the previous video, the project video we have seen is about predicting whether the person has a diabetes or not. So this is a classification problem. But in the case of regression, we want to predict a continuous value, a number or quantity. So in this project, we want to predict the house price. This is not some kind of classification. So house price prediction is a regression problem. Let's try to understand more about our data. Then we will see what is the workflow we will be following. Okay, so I have given a sample data for our data set. So you can see the column in this data, and the last column represents the price of the house are in the thousands of dollars. So the first column represents the median income of a specific household, and the second column represents house age, the age of the house, and the third column represents the average rooms, the number of rooms, and the average bedrooms, and the population, and average occupation, latitude, longitude, and here we have the price of the house. So the first 7 column, we will training our model using the first 7 column, and the last column, that's we are trying to predict. So now let's see how we can solve this problem. This is the workflow. First of all, we need this house price data. So what we need is we cannot feed this data directly to our machine learning model. So we need to do a lot of processing before we can do that by following some steps. After getting house price data, we need to do the data processing steps. So in this step, we will feed our data to a data frame, and in this data frame, we will do some processing. So by that processing, our data will be suitable and compatible to feed to the machine learning model. So once we process the data, we have to do some basic analysis on the data. So we need to find the correlation between various features. So we have seen that the data set has 8 columns. So we can try to see which of these 8 column features aren't related, so that we will be doing in the data analysis step. So once we have some basic data analysis done, we can split the data into training data and testing data. Okay, this is called a train test split. So we will feed this training data to our regressor algorithm, and we will evaluate our model with the help of testing data. The training data has to be done with one type of data, and the testing data has to be done with the new data. That's why we are splitting it. So, and XGBOOST Regressor is a decision tree kind of classification algorithm. It's very much useful for regression cases. So this is extreme post regressor. We need to predict a continuous value or a numerical value, which is the price of the houses. We use the regressor model. So this is the workflow we will be following. So now let's get into the coding part. First of all, you will need to install Jupyter Notebook. After install Jupyter Notebook, you will press on File and New Notebook, and you will get a new notebook. In the new notebook, first of all, you need to install your dependency, your library. We will need this library. So to install these libraries, just write pip install and the name of library. Try to install NumPy and Pandas, Matplotlib, Cporn, and Sklearn, XGBoost, and Scikit-learn. After installing all libraries, we want to load our data. NumPy is useful for matrices, and pandas is useful for creating a data frame. Matplotlib and Seaborn is useful for visualization our data. sklearn.datasets to import our datasets. sklearn.model selection import train test split. We will use this function to splitting our data into training data and testing data. XGBOOST import XGBOOST Regressor. This is our machine learning algorithm that we will use to load our model. We will fit our data using this machine learning algorithm. From sklearn import matrices. We will use this matrices to get the R2 score error and mean square error. To get this R2 score and the mean absolute error. We will use this matrices to get R2 score and mean absolute error. So to load our data, we will import fetch California housing from sklearn to datasets. To load our data, we will make a variable house price dataset. To load our data, we will pass the fetch California housing. To see what had been stored in this variable, just print house price dataset. You will see something like this: data and arrays, some values and target, feature name, house age, average room, average bedroom. So we need to convert this data into a data frame. To convert our data into a data frame, just write BD. This is the abbreviation of pandas.dataframe. This will help you to create a data frame. So just write BD to data frame and the name of your data, house price dataset that we have loaded here, house price dataset dot data, and the column of this data to make the columns like this, and the values listed in each column. So this is our data. We need to name this data by its column's name. So the columns will be equal to house price dataset dot features name. So if we want now to see our house price data frame, dot head will let you to see the first 5 rows of our data frame. Here is our 5. We have here the name of the columns. We get the name of the columns from this house price dataset dot features name. So we have here stored the name of each column in the columns and the data here. And creating a data frame will set the values to its here column. So here it is our data. Median income represent the median income of households, and house age represents the age, average room represents the number of room, average bedroom represents the number of bedroom, average population and average occupation, latitude and longitude. To add the price to our data frame, just write the name price. We want to add a price column, so we want to mention our name of the data, house price, and write price column equal to house price dataset dot target. So this target represents the price of the houses. So this target means the label of this dataset, and this data represents all the other 8 features. So our data now become more structured. To check the number of row and column in the data frame, just write the name of your data frame, house price data frame dot shape. Dot shape will give you the number of row and the number of column. This is the number of row, and this is we have 9 columns. We need to check for missing value. Just write the name of your data frame dot isNull.sum. isNull checks for null value. Null value mean that we don't have a value for our cell. .sum will get the number of null value in each column. So we have 0 null value for median income, 0 null value for house age, 0 null value for average rooms, 0 null value for average bedrooms. All columns we have 0 null value, so that we don't need to cleaning our data because it's already cleaned. We don't have missing values. So now we can get some statistical measures of our dataset. Just write the name of your data frame to describe, and you will get the count of your data frame and the mean of your data frame and the standard deviation and the minimum and the maximum. So this will give the various statistical measures. As you can see here, for each column we have the count. So a count represents the number of data points we have. So totally we have. So these are some important statistical measures. To understand our data set better, now we need to do some more data analysis step here. For that purpose, we need to find the correlation between the data. So I have made a text here, understanding the correlation between various features in the dataset. We have positive correlation and negative correlation. So basically there are 2 types of correlations: positive correlation and negative correlation. So correlation basically represents the relation between 2 variables. So in this data set we have various features or various columns. So we need to find how these features are correlated with each other. Let's say, for example, we need to check the correlation for the first column. which is median income. To get the correlation, just write house price data frame.core. Cores, it's abbreviation for correlations, and we will store the correlations into the variable correlation. To constructing a heat map to understand the correlation, just write plotted figure. Figure size will be in the dimension 10 width and 10 height. So we will constructing a heat map, just write snc.heatmap, and the first parameter will be correlation. The second parameter will be c bar equal true. We will constructing a heat map to understand the correlation. So we are creating the heat map for this correlation value. So this c bar represents the color bar. Color bar is equal to true. So true means we want that color bar in the side. So this is the color bar, as you can see this. So it has various values starting from +1 all the way to negative value to -6 and -7. You know positive value means positively correlated and negative element means negatively correlated. Positive correlated values means that when element increase, it also increase. Negative correlated means when element increase, the other element decrease. So this is the positive correlated and negative correlated values. So the third parameter square equal true. We want all values to be mentioned in a square. And the FMT means you know how many float values do you want to be mentioned. .1 means like I want one value after the decimal point. So see here, I have 1 after the decimal point, I have a 3 after the decimal point. All values are one value after the decimal point. So you can see there is one value after each decimal point. So if I give you 2 here, it will give you 2 values after the decimal point. So that's why we are using FMT parameter. So the next parameter is annotation equal true. So these are annotations. As you can see, all these are annotation. You know features name and all values inside are annotation. And here I have mentioned the annotation size. So basically annotation is all the values and all cells here. It's all features name and all values inside this cell. All these are annotations. So if I increase here the size will be increase of this text, and the numbers, you know, the characters will be also increased. And the next parameter cmap equal to blue. Here I have mentioned the color of our heat map will be blue. Here, as you can see, the maximum value for correlation is +1, and the minimum value for our annotation is -0.75. The square of the color white means there is no correlations between this relation. So this is no correlation between latitude and longitude. That means if latitude increase, it doesn't affect the longitude, and if longitude increase or decrease, it doesn't affect the latitude. And the square that is darkened blue, this means positive correlated. As you can see, 1 is have this color, and here we have the same color. This means we have positive correlated. So medical income, when medical income increase, it also the medical income increase. And when the medical income, here we have a color, it's tends to white, so it tends to negative correlated. That's mean when house age increase, the medical income decrease. So dark color represent more positive correlation, and more white in color represent more negative correlation. So this is how you can find the correlation between various features in a data set through each map. Okay, this is a very much useful for data science analysis, where we need to understand the data more better. Okay, so this is how you can create a heat map. So we have created a heat map. Now we need to split the data into data and labels. So here in this case, the labels are nothing but the price of the data. Okay, so we need to feed this data and label separately to our machine learning algorithm, and through that it can find the pattern between the price and all the data. And this is how it's going to learn from the data. Okay, so now let's separate the data into data and label. So let's make a text here separating the data and the target, and press run. So I will create 2 variables, x and y. So in the x is a variable x, let's include all the data, and in y, let's include all the prices. Okay, so let's mention the data frame. So the name of the data frame is house price data. We will include our data except the price. So we will drop the column price, and we will mention here axis equal 1. If we are dropping a row, we will make this axis equal to 0. And if you are dropping a column like we are doing here, that's why we are mentioning the axis to equal 1. Okay, now we need to store all the labels in the variable y. So what we will do is we will mention the data frame name, the house price data frame, and we will need to mention the column price. So this will store the value of the price column in the variable y. Okay, so I will run the cell now. Let's try to print the variable x, the variable y. See, we have all the data except the prices in x-axis in the x variable, and only the price into a y variable. After that, we need to splitting our data into training data and testing data. So we need to create 4 variables: x train, x test, y train, y test, and we will mention the train test split function. We will pass to this function 4 parameters. The first parameter is x. X is the variable that we have stored all our data frame except the prices, and y is the variable that we have stored the prices in this variable. So the third parameter, we need to mention the test size. So test size is equal to 0.2. So 0.2 represent I want 20% of the data to be in the test data. So 80% of the data will be in the training data. The next parameter, we need to mention the random state equal to 2. So if you use the same value 2 while you are doing this programming, your data will be split into the same way my data is splitting. So if you are using the value as 1, your value will be, your data will be split in a different way. So if you want to reproduce the code, if you want to reproduce how this is splitting is done in the same way, you need to mention the same random state value. So the labels of this data will be stored in the y train, and 20% of the data will be stored in the next y test. So it can be done with the function train test split. So we need to mention the x and y. So we have splitter the x and y here. Now let's see how many instances are in index test. So access the original data, say x dot shape, x train dot shape, x test dot shape. So let's see how many values are there. After running the cell, you will get the number of rows for our original data frame, and we have this number of rows for our splitting data for training, and we have the number of rows for our splitting data for testing. See, the number of testing equal to 20% of our data frame, and the number of rows for our training data is equal to 80% for our data frame for the number of rows. Now we need to loading our model, because we need to train our model. So before we training our model, we need to load our model. So we will loading our model XGB regressor, and we load our model and storing it in the variable model. And to training our model with our data, we will pass to our model.fit function. We'll pass this function xtrain and ytrain. After that, we need to evaluate our model. We need to see the prediction for our training model. Just write the name of your model that you have fit to our data. Mention here the name model dot predict, and pass a parameter xtrain to our predict. What we are doing here, we are predicting the value that we have training the model. We have training our model with training data, and we are testing our model with also the trained data. We just want to see what is the accuracy of our model, what is the squared error for our model. So if you want to see the training data prediction, it will print to you each value he had predicted. So in the previous video, for classification problem, we have used the accuracy score as the evaluation metric, but we cannot use the accuracy score for regression problem. So basically, what we will do in accuracy score is we will check for count the number of correctly predicted values by the model, and the original value. So we cannot find the accuracy score for regression model, but we can find the R-squared error and mean absolute error. So let me show you how you can find those matrix. So we need to compare the prediction of the model values and the original values. So to find R-squared error, we will store R-squared error in the variable score 1, and to find R-squared error, just write matrix dot R-score, and we will pass to this function two parameters. Y train, this is our original data, and training data prediction, this is our prediction. And we will see the difference between this our original data and the prediction of our data. We will store this prediction in score 1. To see the score 1, just write print score 1. See, we have 0.94. This is our squared error. To find mean absolute error, just write matrix with mean absolute error. And the same thing, we will pass to this function the two parameters, our original data and the training data prediction. And to see the score 2, just write print score 2, and this is our mean absolute error. Now we will make our prediction onto the testing data, and this is the important part that we need to do. Because the training data, our model is already training on it. He have seen it before, but testing data, he didn't see the testing data before. So our evaluation now is depending on the testing data. So to test our data, the same thing that we have done for the training data, just write model.predict, and the thing we have changed here is X test. That's why we want our model to predict the testing data, not the training data. To find the R-squared error, just write matrix.R-squared, and we will pass to this function the y-test data. And y-test data is our original data, but the data that the model have not seen before. And the test data prediction, this is the testing data that he have predict. And to find mean absolute error, just write matrix with mean absolute error. And the same thing, we will pass our original data and the test data prediction. And here's our score. See, the score of R-squared error is less than the training data. Here is our project, House Price Predictions.